Hi everyone, welcome. Today we're looking at properties of numbers from section 1-3, and our learning target today is I can identify different properties of numbers. And basically, just to let you know, you're going to see a lot of different properties of numbers today, and I'm going to go through them rather quickly, but I will refer you to the book, and that's where most of these notes came from for this one, is right out of the book. So I'm referring you to section 1-3 of the book starting on page 16, and I want you to look at those properties that are in the tables there as well. And I don't need you to memorize what each property is, but I want you to know the things that are available for you to help solve problems. That's really what these properties are used for, and what they're helpful for is to be able to solve problems. They allow us to do different things with numbers on both sides of the equation that makes it possible for us to solve otherwise really difficult problems quite easily. So they're there to be helpful. And I'm not looking at this as you need to memorize all the properties and all that and spit them out back to me. That's not what I want. I just want you to know that they're there to help you, and there are a lot of things that they allow us to do because they exist. Okay, so let's look at some of the things that are there. So again, first, the properties of equality. Again, this is from our book as well, but we have the reflexive property, the symmetric property, and the transitive property. And here's in a nutshell what they allow you to do. So the reflexive property first says that if you have a quantity, it's going to be equal to itself. So if you have 7, that's going to be equal to 7. If you have the letter A, that's going to be equal to the letter A. That kind of thing. So something is equal to itself, that's what that says. The symmetric property says that if one quantity equals a second quantity, then the second quantity is going to equal the first quantity as well. So that's something like if you have two numbers, A and B, and if A equals B, then B is going to have to equal A too. That's really what that means. So looking at the number example they have, if 8 equals 2 plus 6, then 2 plus 6 is going to equal 8. So it doesn't matter which side of the equal sign they're on. You can switch them. But that symmetric property says that if A equals B, then B is going to have to equal A as well. Okay, then the transitive property just takes a little different take on it, and that says if one quantity equals a second quantity, and then you have the second quantity and that equals the third quantity, then the first quantity is going to equal the third quantity. So in their number examples, if 6 plus 9 equals 3 plus 12, and 3 plus 12 equals 15, then 6 plus 9 is going to also have to equal 15. So what these are really are just saying there's different ways we can arrange these numbers, and they will still be equal to each other. These are properties of equality. Again, you can look at this further in the book as well. Next, we have properties of addition. And the two ones here are additive identity and additive inverse. What additive identity says, if you add 0 to something, it's going to stay right where it was. So in other words, if you have 2 and you add 0 to it, it's going to remain 2. And then if you had 0 and you added 2 to it, it would be 2. So what you're basically saying is that if you add 0 to something, it stays just the way it was. It retains its identity. An additive inverse is what's going to make it equal 0. So a number and its opposite are additive inverses of each other. In other words, they will end up with the answer 0. So if you have 3 and you add a negative 3 to that, you're going to end up at 0. If you have 4 and you subtract 4 from that or add a negative 4 to that, you're going to end up at 0. So basically, if you have a number and its opposite, they're going to end up equaling 0 when you add them together. Okay, so that's addition properties. Now we have some multiplication properties, and again, multiplicative identity says basically if you multiply anything by 1, you're going to be right where you started with. So if you have the number 10 and you multiply it by 1, you're going to end up at 10. You're going to stay there. So it retains its identity when you multiply by 1. Now, multiplicative property of 0 says that if you multiply something by 0, then the result is going to be 0. So anything you multiply by 0 will end up with a result of 0. So if you have the number 20 and you multiply it by 0, it's going to end up equaling 0. So with this multiplicative property of 0, just think about you're going to end up with your answer being 0. And multiplicative inverse basically is saying if you multiply something by its inverse, it's going to equal 1. So if you have fractions, for example, if you have 4/5 times its inverse, which would be 5/4, it will be 20 over 20. And think reciprocals in this case when you're talking about fractions. So if you multiply something by its reciprocal, it equals 1. That's really what we're getting at on this particular one. And then we still have a couple more. Commutative property basically just says that the order doesn't matter. So if you have, this is talking about for addition and for multiplication. It does not work for subtraction or division, but in terms of addition and multiplication, the commutative property says that if you add 4 and 8 together, that's the same as adding 8 and 4 together. The order you add them does not matter. If you multiply 7 times 11, that's going to give you exactly the same result as 11 times 7. Again, the order does not matter with addition and multiplication. And then the associative property, what that's basically saying is that the grouping doesn't matter. Again, when you're talking about addition or multiplication. Again, it has nothing to do with subtraction and division, but specifically with addition and multiplication, if you group the things differently, it will still have the same result. And if you just look at the example down here, 3 plus 5 in parentheses plus 7 is going to equal the same as if you have 3 outside and then you add to it 5 plus 7 in parentheses. They will give you the same result on either side. And likewise with this multiplication example, it will give you exactly the same thing. Finally, we'll just go through one example of how you'll see these problems in the book for practice and similar to what you might see on a test as well. We have the problem 2 times 3 plus 4 times 2 minus 8, and that's in parentheses, equals something. So let's do it one step at a time. 2 times 3, we leave that exactly as it was. Any red here means I've changed something. So instead of 4 times 2, I'm writing 8, and I'm still subtracting 8. So this 8 came about as a substitution. I said that 8 is the same as 4 times 2, so that's a substitution property. And then 2 times 3 plus 0 is going to be, all I did is took the 0 and said 8 minus 8 equals 0. So that's the additive inverse because it made it equal 0. And I just left the 2 times 3 as it was, so I didn't change anything there yet. And now I said 2 times 3 is the same as 6 plus 0, and that's a substitution. 6 is just a substitute for 2 times 3, and then we're almost there. And then 6 plus 0 equals 6, and that's the additive identity. So these here are the properties that we used when we solved this problem. So that's basically what I want you to be able to do is identify what property is being used. And again, we're not going to spend a lot of time on these, but I want to at least give you some of the properties and let you know how they can help us in solving problems. And that's the basic thing I want you to get out of these. Yes, you'll have to identify some because it's part of our standards, but it's not going to be much this year where I'm going to be asking you to identify all these properties. The main thing is I want you to understand that they're there to be able to help you solve problems. And sorry for the length of this video. It's a little longer than most of them have been, but I wanted to give you a chance to I wanted to take the chance to explain some of the properties and hopefully a little bit on how they can help us solve these. So thanks for bearing with me and take care, and we'll see you soon.